Okay, here's warm-up number 36. I've got this equation that involves a radical. So what I'm going to do is first isolate the radical. I'll start by subtracting 17 from both sides. That's going to come out to negative 15 on the, whoops, negative 17. And so, should be negative 25 there. Okay. And next thing I want to do is divide the whole equation by negative 5. So square root of 16x is going to equal positive 5. And then now that I've got the radical isolated, I can square both sides of the equation to get the left side to just say 16x. So 16x is going to equal 25. And finally divide by 16. So x will equal 25 over 16. And you can't reduce that, so you could leave that like that. That would be fine. Or this comes out to 1.5625 if you put it in a calculator. That's fine too. Okay, next problem. Again, I've got a radical here, so you'd want to isolate the radical. Hey, it's already isolated, so let's square both sides of the equation to get rid of the radical. So the left side is just 2x plus 7. A lot of times I'll see people on the right side say that this is, they'll just square both of the terms. They'll say, oh, this is x squared plus 16, or sometimes x squared minus 16. But that's not what we're doing. We're taking this binomial and squaring the whole binomial. So we want to multiply that binomial by itself. And that means we're going to have to FOIL over here. Okay, so I'm going to still leave this side alone. But first, x times x, x squared. Outer is negative 4x. Inner is also negative 4x. And last, negative 4 times negative 4 is positive 16. Okay, and then I'll combine, oops, I forgot my x there. I'll combine those terms in the middle. Okay. And now I'll start pulling everything over to the right side of the equation now because I want to combine my like terms. So let's see, let's combine these constants here. And then I'll also subtract 2x from both sides to combine the x terms. And that's going to leave me with just 0 over here. So let's see, x squared minus 10x plus 9. Okay, so now I've got a quadratic trinomial. I want to solve this. It's already set equal to 0, so that's good. So let's try to factor. And then if we can use zero product property after that. Okay, so let's see. I'm looking for two numbers that add to negative 10. Same two numbers multiply to 9. So negative 1 and negative 9 will work. That's my winning combo there. Okay, and then x minus 1 equals 0 or x minus 9 equals 0. So x equals 1 or x equals 9. Okay, now, especially when you get two solutions like this, you want to test them out. So I'm going to do a little test, and sometimes you could do this test in your head maybe, but I'm going to see, does x equals 1, does that actually work in the original equation? Okay, so I'm thinking to myself, or writing it down, what happens if I actually plug in a 1 for x? Well, on the left side I have the square root of 9, which is 3. Okay. On the right side, I've got negative 3. And you might say, well, there's a positive and a negative root to 9. And that's true, but when you're doing these checks, you only use the positive root. So this does not work. It's extraneous. Okay. So let's check. Doesn't mean that this one works just because that one doesn't. It could be they're both extraneous and there's no solution. So let's check it out. I'll do it up here in this little area. Plugging in 9 into both the x positions. Oops, I had extra parentheses there. Oh well. So 18 plus 7 is 25. 9 minus 4 is 5. I only used the positive root, so this one did work. So x equals 9, but x does not equal 1. Okay, it's an extraneous solution. All right, next up. So this part of the equation, you could write as a radical. You take the 3 would be your index, so this would be the third root of x squared. We're going to use the same kind of technique we did on this problem where we're going to isolate the radical, okay? So you can convert this into a radical right now, but I'm just going to work on isolating first. So I'm going to add 30 to both sides. So 3 x to the 2/3, 3 times x to the 2/3 is going to equal 48. And then, before I put it in radical form, because the 3 is only raised to the first power, right? So what I want to do is divide the whole equation by 3, so that I have the x to the 2/3 isolated. And this is going to equal 16 over here, okay? And now, again, you could write it as a radical, but you actually don't need to. What I like to do on problems like this is just take this side and raise it to the 3/2, which is this reciprocal of 2/3, because then I'd have 6 over 6 as my exponent if I multiplied straight across, right? Which is 1. So that's fine as long as I do the same thing to the other side. And now I've got just x equals whatever 16 to the 3/2 is, okay? Now let's convert this. 2 is going to be the index, okay? Now I could put the 3 inside, but then I'd have a very large number, 16 to the 3rd, inside the radical. For me, it's easier to put it out here because this is just the square root of 16. So that's then 4 to the 3rd, and 4 to the 3rd is going to be 64. So my answer is 64, okay? All right, and the last one, we're going to solve this and graph it on a number line. Okay, so I'm going to start out by solving this kind of in a similar way that I would if it were an equation. So I'm going to isolate the exponent. Okay, now I'm going to square both sides of the equation. So x plus 2 is going to be less than 25, and then subtract 2. Whoops. Oh, I just shouldn't have written the plus 2 again. Sorry. I was doing this to both sides. Okay, so I've got x is less than 23. A lot of people will just say that's the answer, but that's not the whole answer. Anytime you've got a radical with an inequality like this. And notice there's no y, so I'm not graphing this on an xy graph. There's only one variable, but I have a radical, and it's an inequality. You got to think, well, this number, this value underneath the, this is called the radicand, what's under the radical has to be 0 or greater. It can't be a negative number because then I've got imaginary numbers. There's nothing wrong with imaginary numbers, but I can't graph them on a number or a regular number line. So then I want to take the radicand and make sure that the radicand is, it can be 0, so it has to be greater or equal to 0, okay? So in this case, x plus 2 is my radicand. X plus 2 is greater or equal to 0. And now I still need to solve this, so just isolate the x by subtracting 2. And now I've got the second part to my solution. So these are both legitimate parts here, okay? So here's my solution. And then let's actually graph this on a number line. So I'm going to put just these 2 points on the number line and make sure that -2 is to the left of 23, because that's how -2 is less than 23, right? Okay, and above the -2, this is going to be a closed dot because that's underlined. This one's going to be an open dot, okay? And then I just look at each part. So it's greater than -2, so it's going like this, right? But it's also less than 23, so from the 23 it's going this way. So it's going to be connected between those 2 points. And there's my graph. Okay, that's the end of the warm-up, and I'll see you next time.